Don't worry, this image isn't meant to be a metaphor about the material that we're about to delve into. It's merely a representation of the new problem that we're about to begin. Alright, so if you can't tell already, this happens to be a skydiver jumping from a plane. It is the best I can do. Don't laugh. Alright, so one of the things that I want to talk about, you've had some experience with functions, ordered pairs and graphing and tables of values. But I just really want to go over them just to solidify that fact. And then we can delve in even deeper into what Algebra 2 truly is and why it's so important in mathematics. Alright, so one of the things that we deal with in algebra is a relation. A relation. And a relation is a set of pairs of input and output values. So this is a set of pairs of input and output values. So there are different ways to represent relations. One of the ways that we can represent relations is with ordered pairs. You may have seen ordered pairs before. They are just an input followed by an output, or you may have seen them as x comma y, or just a set, a pair of numbers, such as -2, 5. Another way of representing relations is a mapping diagram. A mapping diagram lists inputs and outputs, and just output. And we can list these as maybe -2, -1, 0, 1. And then these relate to outputs, things that your function is actually giving out with these inputs. So maybe 7, 9, 12, 13. And each one of these inputs pairs with one or more outputs, like so. So it could be more. One input could pair to more than one output. That is a possibility. Another way that we can represent this is with a table of values. Table of values. A table of values again lists input and output. And in the same way, this may list your inputs as -2, same, we'll just use the same inputs, -1, 0, 1, and then your corresponding output. -2 paired with 7, -1 paired with 9, 0 paired with 12, and 1 paired with 12 and 13, so we can actually write 1 twice. We'll put 1 here, and then we can put another one here and put 13. So that would be an example of a table of values. And then finally we can also represent a relation with a graph. So you have seen the traditional x and y axes, the x-axis and the y-axis, and then you can make these ordered pairs into actual points on the graph as they correspond to the values. I'm not going to get them exact right now. All right, so going back to our original drawing over here, the man or woman jumping out of the airplane, then we can actually represent a relation using this example. So let's say this man is actually jumping out of the airplane, and you want to represent the input and output of his time that he's falling to the output of his height at any point in time. So we can actually represent this using just inputs and outputs. So if we were to do this using ordered pairs, well, we could say, if we wanted to start this here, we could say that the first ordered pair at 0 seconds, he starts at 10,000 feet. And then he falls a bit, and then at 4 seconds, he's at 9,744 feet. And then at 8 seconds, he's at 8,976 feet. 76 feet. And then at 12 seconds, he's at 7,696 feet. And finally at 16 seconds, right before he pulls the chute, he is at 5,904 feet. Okay, and then we can close this like that. All right, so that would be an example of a set of ordered pairs. This gives an input followed by an output with time as a relation to height. Okay, so the same thing goes for a mapping diagram. We could create a mapping diagram. And this mapping diagram would correspond in the same way. 0 would be paired with 10,000, 4 with 9,744, 8 with 8,976, 12 with 7,696, and 16 with 5,904. Okay, simple enough. If we wanted to create a table of values, we actually only have, for our inputs that we have here, for our inputs followed by our outputs, each input is paired with exactly one output. So a table of values would essentially be the mapping diagram, but instead of the arrows, you could draw, let's see here, we can actually draw it. You could draw a table of inputs and outputs. Okay? All right, so we have our ordered pairs, we have our mapping diagram, we have our table of values. The last one that we discussed is a graph. So let's go back to our original yellow. And then we can actually make a graph here, and we could make a y-axis followed by, oh, that's not very straight, an x-axis, And our y-axis would be measured in feet, because that's our height, and our time would be, our x-axis would be measured in seconds, because that is our time. Then we can put 0 as our origin, and then we can go 4, 8, 12, 16, 20, 24. And then for our height, we can measure in, here's a little notation that maybe you haven't seen but is quite useful in graphing. If ever in graphing, and this happens many, many times in the y-axis, where your scale is so completely different, and maybe on the y-axis you don't want to start, you want to go by thousands, maybe you want to go 5,000, 6,000, 7,000, 8,000, but you don't want to start at 1,000 because your data doesn't begin until after 5,000. Well, what you can do is actually make a little line, then make kind of like a little squiggly right here, and then continue the line up further. And then that says that there's a bunch of numbers down there that you haven't actually written, but they're there. They haven't disappeared, they're still there. So we can make that little squiggly, and then we can just start our graph at 5,000. Much easier. And then we can go 6,000, 7,000, 8,000, 9,000, 10,000. All right, so at 10,000 we start at 0, and then we start to decrease in height, and I'm just starting to make some generalized points here. And that's all we went up to. We went up to 16 seconds. So it's going to come, maybe this one's a little bit further down than where I put it. Get rid of it. Maybe this one's, oh. Maybe this one is, oh, this is all over the place. It's down here. All right. So we have a general curve here, which represents our inputs, time, followed by our outputs, height in feet. And we can start with our first ordered pair 0, 10,000, all the way down to our final ordered pair of 16, 5,904. All right? And that is all I'm going to say for this example.